One. It's not.
Actually, it has a one plus. Well, if enough kids come in person, I'll come in person. All right, so what's your audience? So our next application has to do with determining maximum points and minimum points. All right. So before I show you that, I want you to remember something, right? Let's say I gave you a minimum. Right? Where is the minimum point again? Right away. Minimum point is right here. That's okay? That is the minimum point. Right, quick question. If I draw a tangent at that point, what will it look like? A straight horizontal line, right? Not straight, they're all lines straight, right? It'll be a horizontal line. You okay with that? So if I said find the gradient at, find the gradient of the tangent at the minimum point, what would it be? 0. What's the gradient of this line? 0. So dy dx at this line is what? 0. So what does that say? It says here that when dy dx is equal to 0, we have a turning point. Right? So a turning point occurs when dy dx is 0. Everybody okay with that? How would you know if it's max or min, Chris? What positive or negative?
The A value.
A value. If the A value is more than 0, or if the A value is more than 0, we have a minimum. And if the A value is less than 0, we have a. Why am I writing so small? Sorry, online. Right? So, what should going to happen here? Watch this here, right? What does a quadratic look like again? So generally, y is equal to ax squared plus bx plus c. Everybody okay with that? So if I differentiate that, what will I get? What will I get? I'll get 2 by a by x plus b.
Yeah.
And if I double differentiate, remember what's double differential? Going again. If I double differentiate, what will I get? 2a. Very good. Because the differential of p is
0.
And the differential of 2ax is 2a. So I have a little question again. We just said that if a is more than 0 is a minimum, and if a is less than 0 is a. How can d2y dx squared help me determine if it's a maximum? Huh? We'll be able to know, right? So if a is positive, if this value turns out to be positive, right, let me ask something else. How I can make this value positive? How can I make d2y dx squared positive? What controls it? A, right? So if a is more than 0, won't it still be a minimum? So if I put a value more than 0 here, and I'll get this to be more than 0, so it will be minimum. And if a is less than 0, it will be a maximum. Are you okay with that? So in short, you don't have to learn all that, huh? I just showing you where it came from. What new, right? Right, so yeah. So in short, here's what you need. To determine if something is max or min, you have to check the second differential. If the second differential turns out to be more than 0, it's a minimum. If the second differential turns out to be less than 0, it's a maximum. So it's real simple. I'm going to give you an equation. You have to differentiate and check and see if the value is more than or less than 2. That's all. Okay? Copy it down. Copy down from here. Yeah. Yeah, that's right.
Yeah.
Not here. Here.
The UL was it.
Right, so those are the rules. Whenever you see a maximum problem, that is what we're working with, right?
Island.
All right, so ready?
Yes, it's
Oh, well,
device back.
it's d2y dx squared.
Oh.
Watch y, right? So when you differentiate something, you differentiate in y, right? Let's say it's 2x. You differentiate in y with respect to x. When you differentiate again, differentiate in dy dx with respect to x. So it becomes d by d squared dx by dx. Right? So that's why we. So you don't put it 2 here. Put it 2 by d and by d. Right? That way you also set and back so right? Online, are you okay? All right, so let's try an example. So now the sheets can finish right. Ready? I think it's off, right? So I want to show you something here, right? Some questions real simple. What they will do is they'll give you a function and ask you to find the nature. Nature simply means, is it a maximum or minimum of some stationary points? Okay? Ready? So I'll do this first one here for you. Let's start easy, right? Let's start medium. No, starting easy. Really easy. All right, ready? So let's say I gave you what's here first now, and then you'll copy it down, right? Let's say I gave you a cubic first. And in the cubic, I said, okay, this cubic has some stationary points. I want you to find them. So it might look something like that, or it might look something like that. I want you to find the stationary points and then tell me if they are maximum points or if they are minimum points. That's okay? So let's see if we could do something like that. So first thing first, we gotta get the stationary points. So here what we learned. We learned that stationary points occur when dy dx equal to 0. Right? We learned that earlier, right? When dy dx is 0, we have stationary points. So we differentiate that. What's the differential of that? 3 by 3 is 9, that's 9x squared. 2 by 2 is 4, that's 4x minus 3. And the differential of minus 3 is 0. That's okay? So the differential of this is this. Right? To get the stationary points now, we have to see the x values when dy dx is 0. So we take 9x squared plus 4x minus 3, make it equal to 0. Come on, take any calculator now? Anybody? Fast? No need to use the long formulas, just put it in the calculator, tell me what you get. Put it in the calculator, tell me what you get. 9, 4 minus 2. What's that? Coming up. Minus trouble. Oh, hold. Probably one way cap after. I didn't check. 9 by 3, 9. 9 minus 3 is 6. 9 minus 3 is 6. .1 decimal place. 0.4 and negative 0.8. All right, so y'all get that? The calculator. I mean, work it out. How do you know it right? Anybody else get that? Yeah, good. So in the calculator now, we have two values. So right now, Leo, watch here first. Step one. Why are you doing that? Oh. So if you watch here, you have two values. These are your stationary values, right? But we still need the y value. We'll come back and find that after, right? And yeah, this is how to get it. If we know the x, how we find the y? This one here, right? Or we do that after. Right. We have 2 points here, Shelby. How do we know which is max and which is minimum? These are two turning points. but we don't know who is max or who is min. So what we have to do now is to find d2y dx squared and then put in the x value and see what will happen. All right, so watch this here. To help me differentiate that there, Saraya, what's the second differential of that? What's the second differential of this? You differentiate this, right? Sorry? 18x plus 4. Right? That is your second differential. Now we have to determine, Chris, if it's max or min. So we're going to unplug in x is 0.4. So we will get d2y dx squared is 18 by 0.4 plus 4. It doesn't really matter too much, but I know it's more than 0. Right? So therefore, it's a minimum. You okay with that? Then we do the same thing again. When x is minus 0.8, we have d2y dx squared is 18 by minus 0.8 plus 4. Work it out, and you'll get something less than 0. Therefore, it what? Maximum. That's all. Right? All you're missing is to find the y value. Okay? To find the y value return, we put in the value here. Plug in 0.4 here, and you'll get the y value. Plug in minus 0.8 here, and you'll get it out. Okay, copy it down. Copy it down and just tell me the y value. So, what are the steps? What are the steps? Find dy dx. Make it equal to 0. Solve square. Find d2y dx squared and plug in the value. Okay? Writing all the steps, and let's go again. Right. You shift while you're writing. Tell me the steps again then. Find dy dx. Find dy value. Yeah. Make it equal to 0 and solve, right? Try and try that. Probably 2%. Now done? What's your got for y? When x is 0.4, what's your got for y? Anybody else? What you all get for y? Plug it in here earlier. So you're finding 3 by 0.4 cubed plus 2 by 0.4 squared. That's what you're doing, right? Much yeah. Online you can message the answers too. Minus what? Both minus. That is minus 3.4. For this exact thing, you know, tell me what you got. What you got?
Minus 3.
Minus? Minus 3. What you got? Minus? So minus 3.7. And what's the next one? Minus 0.9. Right? So the minimum point is 0.4 minus 3.7, and the maximum is minus 0.8 minus 0.9. That's what it?
Yeah.
Online, all you get that? No, it's up. You all get that? Yeah? Anaya? All right, nice. Right. Don't have it. No, okay.
Hey.
Right, let's go again. Let's go again. June 2014. June 2014. June 2014, given that f of x is equal to, it's a June 2014, number 5. Given that f of x is equal to 2x cubed minus 9x squared minus 24x plus 7. Part 1, find all the stationary points. Part 1, find all the stationary points. So please find x and y. Part 1, find all the stationary points. And part 2, find the nature of each stationary point. Okay? Find the nature of each stationary point. Oh yeah, you got that fast there? Online, just message your stationary barcode, please. Everybody here, please. Sorry, na YouTube. Sige. Ito. Online do forget it. Done? Online, send some values then up, please. Right, so remember, we could write dy dx, Josh earlier, we could write dy dx like this, without prime sign, right? Mean the same thing. You'll get 6x squared minus 18x minus 24. And remember to write this. Stationary points occur when dy dx is equal to 0. So you take 6x squared minus 18x minus 24, and you'll get what? X's? 4 negative 1. Nice. And then let's find the values one time. F of 4 is 2 by 4 cubed minus 9 by 4 squared minus 24 by 4 plus 7. And you got? So your first point is 4 minus 105. That's okay? That's the first point, right? And then you find f of minus 1. So that'll be 2 by minus 1 cubed, 9 by minus 1 squared, 24 by minus 1 plus 7, and you got 20. So your next point is minus 120. So we have that. Now, second differential. Your second differential is 12x minus 18. Yeah? And we just go and plug in x is 4. So I'll get second differential of 4 is 12 by 4 minus 18. That's what, 30? More than 0. Therefore, it's a minimum. Therefore, give them the point here one time. Minimum point is 4 minus 105. And then when x is equal to minus 1, f double prime minus 1 is 12 by minus 1 minus 18, which is minus 30, which is less than 0, therefore, maximum. Right? Maximum point is minus 120. Right? I mean, you don't have to draw it, but I just giving you a little idea of what it might look like. We're not sure if it's going to zeros, no. And not going to 0, 0, right? So that's 7. So here might be a maximum, that's minus 120. And here might be a minimum, which is 4 minus 105. But it's way more elongated than that, right? You're okay with that? So this is technically what it might look like. It's not passing through the original, it's passing through 7. No, I'm just giving you an idea what it might look like. This point maximum, this point minimum. That's okay? Right? So that's the way it works. Let's do one more easy one, make it think it easy, and then
Think it easy.
then we get some worded question.
So it's just big old something. I don't mean it's right.
So we check out online, and when you get 2 answers, and when that start to become people. Right, good job, Anaya. No. Very good, sir. Serena. Chelsea, I need answers. Oh, yeah. Alyssa, I need answers. Diego, are you there? I didn't get a response from you since Saturday. Diego, are you there? Diego, you're there, okay. some answers that Caleb, you too. And Sydney, you there? Sydney, you okay with differentiation, right? Okay. So what's your all right, next one, 2015, number 5. 2015.
No.
That's a good idea. I died. She shall like how you think. I know John in our podcast. Hold on, earlier. She's what he holds it. Yes, I like that. Like some practice, right? Yeah, the thing. Well, kasi yung things shot here.
What?
Oh wait, they cut it off. Oh, they go. Alright, look at that. This one here, right?
Sorry.
That's 2015 number 5, part B. So you're working out this part here and this part here. That one are you ready? So the one I give you was 2x cubed minus 9. It's kind of come the same as the all the same. Which is the very next thing I say. Which is go around. Hey, you're watching the wrong one.
Wait a minute. Let's see that. There's a one.
You're doing the one underneath. Yeah? You're doing the one underneath, right? Right? Sydney, you tell my answer. Tell me the point and it says maximum in. I fill it too. Why did we go down?
I don't need to take a look at it.
dx. So quadratic. Significant figure. Hi.
So, that's my mommy.
Okay. The shelter and second side. But okay, what needs to be outside?
Oh, this is. Wow.
Okay, yeah. All right. Yeah, yeah. I got four. That's wrong with it, or don't, yeah, you want to, you know, that you will.
I haven't looked into it. What is it that I was just running? Something. Yeah. Hi. I don't know. Well,
What do you want? Yeah. Started. Up. Right, go ahead.
oh. I think I know everything.
Right online, send some answers there. I fill with none yours. I failed the job, let's you see it right. And wait, not Sydney. Did Sydney send hers? Not yet. I'll kill her, I've Sydney or send it, man. I've Sydney. I've Alyssa, nice. And Narissa. Okay, nice. Let's check it out. Right. So first thing first, what do we need? We need. I'll just find both of them one time, right? dy dx is 3x squared minus 10x plus 3. And I'll just find d2y dx squared one time, right? 6x minus 10. So what do we need? We need it's always important to tell them why you're writing something, right? So you tell them that stationary points occur when dy dx is equal to 0. So you don't magically just write dy dx is 0, right? So now you write dy dx plus 3 equal to 0. So you're telling them why, right? Why all of a sudden it became 0. You went to calculator and you got what? 9 and something? No? 3 and a third? Positive? Both positive? X is 3 and X is 1, 2. Yeah? And then you come back here and find your Y value. Y is what? Well, when X is 3, Y is -8. And Y is 40. Anybody just get up? 40 and 27. Yeah, we done. Yeah, once we done. Huh? Once we done get out, we go with that. Now, when X is equal to 3, you have to find d2y dx squared. That'll be 6 by 3 minus 10, which is more than 0. Therefore, minimum point is 3 minus 8. Huh? Right bigger, sorry. d2y dx squared is 6 by 1/3, which is less than 0. Therefore, maximum, just show us right now. Maximum point is 1/3, 40 on 27. All right. Good job. Right, so I don't you all think it's so easy. Because sometimes only once before, right? 2019. After this question, this format here wrong. Thank you, Ron. All right. Let's just take a look at what came in 2019. It was a little bit different, right? Right. What is here? Real pressure here. What we going to do here? Huh? I suppose no. What book this one? Right. So what is here? This question said what here is what? These are the stationary values. How can you find dy dx from that? So before you think about it, look back at your answer and see if you can go backwards, right? Alright, yeah. Think about it and then I'll take some answer. Anybody online can message? How do we work backwards here? Yeah. Yeah, here. Reverse, what does that mean? He turned. Wow, what was he doing that? Yeah? Your hand is up first, yeah? Just one order this now.
And we just read it line x minus 5 multiplied by in bracket multiplied by x minus 3. That's like the possible in our parents for okay, I'm multiplied by 10, and then you put the question, okay?
Okay, so what Serena saying there, right? Is that remember, how do you normally get 5 and 3? And kids normally get 5 and 3 from here? Yeah? So can you take x equal to 5, x equal to 3, work backwards and get equal traffic? And yeah, so what you have to figure out now is always try to figure out, okay, I am here, Chris. I am here. How do I get back here? Right? So the way to get back there is exactly what Serena said. Serena said that to write x minus, because these are the x values, right? So you write x minus 5, Chris, and x minus 3. Okay? And then you expand it out, and that will give you the what? That will give you the quadratic. This is 2019. So every now and again, you see this question out of the blue. We have to be able to figure out things like this, right? Okay? Oh yeah. Expand it out and more again. Expand it out and more again past. Still have more data. Right? Yeah, Vishi, you want me to have them again? X squared.
Minus 3x minus 5x minus plus 50. So yeah.
Right, so earlier, this could happen in an exam, right? You can see a question I never did before. What you have to figure out is how to take what it gives you and go backwards. How to take what it gives you and make it look like something you've been working with all the time. Okay? So you would recognize, okay, when I have x is 5 and I have x is 3. Those are the stationary values. How do I normally get those stationary values? Factorize, so on. Right? So what I showed you there, the steps you go, well, the steps you would take, right? Step 1, step 2, and step 3. Right, the next part, I didn't show you how to do it as yet. Oh wait, no, you can do that. Next part, find the nature. I didn't show you the third part. I showed some people. Find the nature now, please. Find the nature. Oh yeah.
So God, I'm sending text. Was on the phone.
Next time. Alright, hurry up, hurry up. You gotta set the gear schedule, right? So have 1, 3 to 5 in a way, right? Why she put message in there?
So because she went to see us.
Hurry up, find the nature, please. Already done? I showed some people, but I don't remember. That's how you get that one. So what can you help with? What can you help? Just how you went from Y to Y, yes. So that yeah. Because you can take it out.
Yeah. Oh, and to get this part, it would be. It would be right.
Alright. You all find the nature. So d2y dx squared x squared minus 8. So we're going to plug in x is 5 and I got d2y x squared is more than 0. That's okay? So when x is 5 is a minimum. And then we're going to plug in x is 3. Both are minimum. 3 squared is 9. What's up? I want to know why I wrote. No, I wrote the wrong thing, sorry. I with x squared. I was switching the differentiation.
So I see.
No, no, like. All right, everybody okay with that? So 5, 11 and 2/3, that is your minimum point. 315 is your maximum point. All right? Right. So maximum and minimum problems could also be worded problems, Chavi. You can try some worded problems now. You can try, yeah. Oh, and a third part, yes. Sorry. Can the third part though? Right? I didn't teach everybody the third part. Those who were here any holidays did the third part. But I don't want you to do the third part today. But anybody tell me how to get the equation of the curve? How to find the equation of the curve? How do you move from dy dx back to y? Integrate. Right? Integration that we did over the holidays. Yeah, right? Alright, but ignore that, right? I'm not doing that. I'm not reviewing that. Alright. Sometimes you get questions that look like this. Right? Sometimes you get questions that are worded, right? So let's see if we can try one. Given that, right? We can do two, that is perfect. Right? So sometimes questions are not straightforward where they give you an equation, and a differentiate or differentiate. Sometimes they'll give you a scenario or a life situation where you have to maximize or minimize. Some HBAs are based on this one question. All right? Try this one first. Given that x plus y is equal to 6, given that x plus y is equal to 6, find the values of x and y. Given that x plus y is equal to 6, find the values of x and y which give a stationary point of the function t is equal to 2x squared plus 3y squared. This is now, you coming on the board actually. T is equal to 2x squared plus 3y squared. T is equal to 2x squared plus 3y squared. And determine whether they make t a max or a min. And determine whether they make t a max or a min. All right? Right. So I'm going to talk through a few things. Here's what they give us. They told us x plus y is equal to 6. That's okay? And then they said, find the stationary value of t, right? And then determine if it's max or min. So my first question to you is, what's the problem with this equation?
Actually, like.
It have a y squared. So the y squared is a problem, right? Suppose it had x. Would it have been simple? So in your mind now, you had to figure out how do I go from y to x. time will be close to it. What we can do to get rid of the y? Very good. So if you substitute, you'll get 2 is equal to this by this. Now, what you have? You have an equation in terms of x. Can you differentiate? Double differentiate? Do you think, Puff? Right, so again, Oliver, in exam, this question will not come, but the process will come. The process where you see the problem and you have to figure out how to fix it. The problem is a y. How do I get rid of the y? There must be a way, right, Aaron? How do I get rid of the y? I have something else here, right? And I make y the subject and I get rid of it. Right? That's your objective. How do I get rid of that y? Go ahead. With this.
Substitute.
That's a substitute.
It's fine.
Right. Yeah, we study. And that's true. Yeah, what I
I have expand it out and then differentiate. I guess we have one more to get. I made it happen. Right? How much we got here? Oh, wait, no, you solve this thing. So you'll get 10x minus 36. So you have to find dt dx, because I think they have to the stationary point as well. So dt dx equal to 0. You'll get 10x minus 36 is 0. X is 36 on 10. X is 3.6. Right? They asked for that, right? X is 3.6. But they asked for X and Y. Right? And we need the Y value as well. So Y is 6 minus 3.6, which is 2.4. Okay? And then you have to find d2t dx squared. Right? So that will be 10. Therefore, it's a minimum. Davi, are you okay with that? Online? You're okay with this? We have one more type to do, but it might not have time. We have one more to do, but one more type, but I can squeeze that. You can do it, that change that we have one.
And then you give me
Have this one? Everybody okay with that? Online? You're okay with something like this? Right, so step one, you understand the issue? The issue is that variable here, that y. Okay? So I just want to point out one thing here and then you wrap up, right? I think I have it here. Sydney, you're okay? Serena? Sophia, you're okay? Right. Watch this one here. Last one for the road here. This is a real life scenario, right? So right. So you might see this in a SBA, right? All right. You have a next one? Stefan, read this one. I mean, Chris, read it. In fact, Stefan, for listening to him, read this.
What?
Yeah, you should be listening to him. And you should be encouraging him not to be on the phone. So what you say? Right, read it. Yeah, read it, man. So the length of a closed rectangle, right, is a closed rectangular box. So the length is 3 times the width. If its volume is 972, find the dimensions which make the surface area minimum. Right? So this one totally new. Right? We didn't do any like these, but it's the same principle. What do you want to minimize? What do you want to minimize? Area or volume? Area. Area. You okay with that? So you want to minimize area. Can we find an equation for area? Right? Area is? So that's volume. Right? Area is what? Area is what? Length by width by 6 sides, right? So you have to work it out. So it will be 2 times Now listen, 2 times x by y plus 2 times 3x by y plus what? What's the last side that missing? Huh? 3x by x, right? 2 times 3x by x. Right. Can we maximize that? I'm sorry, can we minimize that, Yasin? No, we have a problem. Problem is the what? The y. And Chris, take it back your phone. How we get rid of y, right? How we get rid of the y? Think of the last one that we did. Substitute what? Very good. You have the volume as. And highest find volume again, same thing Kyra said. Right? Length by width by height. You're okay with that? And you'll get back y. And then you can find the differential. So then you handle that. So again, my point of this whole thing is for you to see what you have to minimize, how to get the equation, and how to get rid of the next variable. Not ready. It's like a paper tree. It's like a paper tree. But it can come on your syllabus, it can come. Right? So I'm gonna give you a few of these. Screenshot this one and send in the group and do it for homework now, please. Anybody can screenshot it?
I can't take my picture now, is it?
Screenshot it and send it. And she said, I screenshot it for next.
Take my picture.
All right, so for homework, I want you to work out that. Okay? All right, online. So we'll continue from right here next day.